Hey everybody, we are still talking about systems of equations. I know it's exciting. We're coming down to the end. And so now we're going to talk about all the different tools that we have in our tool belt in order to solve systems of equations. All right, so here we go. Let's say I gave you these three systems. So we've got the one in black, the one in blue, and the one in green. I want you to think about what method you would use to solve each of these systems of equations. So you could graph them, you could use substitution, or you could use elimination. So here's my thinking. Whenever I see a problem of two equations that I know I can really easily graph, so I've got two things in y equals mx plus b form, I'm going to go ahead and graph that one. The second one, I would say that I would use substitution here because whenever you have a variable that is isolated, so we've got one y equaling blah, 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 you know that you can plug that into the second equation for the y that you see here. So what I would do for this second one is I would say use substitution. And now for this third one, whenever both equations are in this form, that ax plus by equals c form, so that looks like this, ax plus by equals c, we would use like the cover-up method, right, when we were graphing these. Whenever it looks like that, I would use elimination. So here's just sort of a general rule of thumb. Now, the one on the left that I said you could use graphing for this, you could also use substitution. Because do you see how you have two things that are both equal to y? Well, that means that they're equal to each other. So you could actually use substitution for this one as well, and you could set up an equation that looks like this. 3x plus 2 equals 2x plus 4, because if y equals y, then those two things equal each other. So keep that in mind as well. But just sort of know that you've got these three tools and there are more efficient ways to use them. We'll talk, though, about how really for every system, you can use all three methods, which is pretty crazy. All right, here we go. So I'm going to give you the system, and I want you to think about which method you would use first. Would you use graphing, substitution, or elimination? All right, so hopefully you said that you would use elimination here. And the reason why is because both equations are in that ax plus by equals c. So go ahead and solve it. All right, so here's what I did first. I saw that I could pretty easily eliminate my x's. So I multiplied everything on the bottom by -2. So that gave me 10x plus 2y equals 12, and then negative 10x minus 14y equals negative 48. All right, so then that was the multiplication part. Now I need to add them together. I'm going to drop that guy out. And then I get 2 minus 14 is negative 12y. Negative 12y equals, so 12 minus 48 is going to be a negative 36. And then if I divide both sides by negative 12, I get that y equals 3. That is only half of that's only half of my solution there. I've got to plug it back in. So remember, the cuteness and the quality of your plug really matters. Yeah, oh my God, so cute. Okay, so I'm going to plug it into either one of those equations. So I'm going to choose the second one, 5x plus 7. And now instead of y, I'm going to plug in 3. So I'm using substitution here. And then equals 24. So then 5x plus 21 equals 24. So then 5x equals 3 if you subtract 21 from both sides. So x equals 3/5. So my solution here, remember, the solution to a system of equations is where the two lines cross. So my solution would be 3/5, comma, 3. All right. Hopefully you knocked that one out of the park. Let's try another one. Okay, here's the next one. So I want you first to think about which method you would use, graphing, substitution, or elimination. Okay, so hopefully you said here that you would use substitution because you saw this lonely y and you know that you can substitute it in here. So let's do that. So I know that y equals x minus 2. So I'm going to rewrite that first equation, but instead of y, I'm going to put in x minus 2. And the way you know that you have done this correctly is if you look at the equation that you've got, you know that you only, or you see that you only have an x there. So if you plugged it in and then you all of a sudden in your new equation, you've got an x and a y, then you know you've made a mistake. All right, so if I do this out, I get 5x plus 3x minus 6 equals 26. So I get 8x equals, and I'm going to add 6 to both sides, equals 32. If I divide both sides by 8, I get that x equals 4. Okay, and then remember, the second piece is that super cute plug, and I even do a little smiley. Oh my gosh. Okay, so then I'm going to plug it into that second equation. So y equals, but instead of x, I'm going to plug in this 4. So 4 minus, oops, minus 2. So then you get that y equals 2. So your solution here, remember, is a coordinate point. It's going to be the coordinate point 4, comma 2. All right, moving on. Last one. I want you to solve this system, but first decide if you're going to use graphing, substitution, or elimination. All right, so I chose graphing for this one because I know that I can easily graph the two of these. The problem is if you go ahead and graph something like this and you can't clearly see where they cross, this is when I would use that substitution that I talked about earlier, where you just set the two of them equal to each other. But let's go ahead and graph this and just see what we get. So I'm going to graph this first. And there's my y-intercept, and then I'm going to go up 1, 2, 3, 4, 5 over 1, up 1, 2, 3, 4, 5 over 1. Let's slip and sloop. So 1, 2, 3, 4, 5 over 1. All right, so there is my first line. Pretty steep sucker there. All right, and now let's try the second one. So I'm up 1, 2, 3, 4. And then I go up 2 over 1. Oh, amazing. Don't have that much to do because look, they crisscross really nicely right here. So the solution to this system would be the coordinate point 1, comma 1, 2, 3, 4, 5, 6. And that would be your solution. Woohoo! Again, if they don't cross at a nice place, that's totally fine. And you can go ahead and do substitution here. All right, so one last thing I wanted to talk about. Let's say that I gave you this system of equations. First, what would be your gut instinct? How should you solve this? So I would definitely say elimination. And if you said elimination, amazing, you're in great shape. So I want you to go ahead and use elimination to solve this system. All right, we're back. Now, if you use elimination, what I did is, and you could have done something different, what I did is I multiplied everything through by -3 in order for my y's to drop out. But you might have tried to get your x's out of there first, and that's totally fine. So your final solution here should have been the coordinate point, -3, comma 6. If you didn't get that, go back and double check your work because now I want you to solve the same system, but now I want you to use substitution. And I'm going to do something first to make this a little bit easier. I'm going to change this and rewrite it in that y equals mx plus b form that we've done before. And all I'm going to do here is just subtract 3x from both sides. So this system or this equation would be y equals -3x minus 3. So now you've got a nice little substitution situation here, right? Like you can plug in this for y into that one. So go ahead and try it. All right, we're back. Now, did you get the same answer, -3, comma 6? The answer should be yes. Okay, last one. Now I want you to solve the system by graphing. So hopefully you plotted your points and you felt really comfortable, but let's do it quickly together. So I'm going to graph this first one using the cover-up method. So my x-intercept is going to be 2x equals 12. So that's going to be 6. So 1, 2, 3, 4, 5, 6. So this is a coordinate point 6, comma 0. And then my y-intercept is going to be 4. 1, 2, 3, 4 because 3y equals 12, so you solve. So, ooh, that's kind of nice. I've got a nice little straight line here. Try and extend this as much as possible. It's not perfect, but that's okay. All right, and now let's graph this guy. So remember, we scooched it around before, so I'm going to keep that. So y equals negative 3x minus 3. So let's go down to negative 3 as my y-intercept. And then my slope is also negative 3. So I'm going to go down 1, 2, 3, and over 1. And then I'm going to go up 1, 2, 3, and over 1, and up 1, 2, 3, and over 1, and up 1, 2, 3, and over 1. Interesting. So thank goodness this all worked out. So you know that we have not been lying to you. Look where the two lines cross. They cross at negative 3, comma 6. So you see, you've got a lot of tools in your tool belt. You can attack any system using all three methods, but there's always going to be a more efficient way to choose. So hopefully this all went well, and we will see you guys soon. Thanks.